Adrenal glands. Adrenal glands are triangle-shaped glands located on the top of the kidney.
The adrenal glands, located on the superior aspect of the kidneys, are responsible for the release of several hormones. The adrenal cortex secretes glucocorticoids that respond to stress by increasing blood glucose. It also releases mineralocorticoids that maintain electrolyte balance by acting on the kidneys. The innermost layer of the adrenal cortex secretes small amounts of sex hormones that resemble testosterone.
The outer part of the adrenal gland is called the cortex and produces estrogen hormones such as cortisol, aldosterone, and testosterone. The inner part of the adrenal gland is called the medulla, and it produces epinephrine and norepinephrine, which are commonly called adrenaline and noradrenaline.
So those are just a couple of the signs that you have an adrenal imbalance that you need to have your adrenals tested. So what happens when your cortisol levels remain ramped up or they remain elevated for a prolonged period of time? Well, obviously it depends on the individual, right? All kinds of symptoms and the long-term health problems that can occur down the road have been linked to anything from neurodegenerative diseases where your brain's being affected, things like Alzheimer's disease, things like memory loss. We actually know that under prolonged states of stress, areas of gray matter can be affected that are associated with the doctor, and he or she tells you that your blood work looks normal, but you continue to experience all these signs and symptoms that we just talked about, you're going to know better, okay? I'm Dr. Hagmeyer. I hope you enjoyed today's video. Stay tuned for upcoming videos in this video series that we're going to be doing. The next video I'm going to talk to you about is going to be how to test for this adrenal disease and just some of the causes that are behind adrenal disease. So I hope you enjoyed this video. Take care.
They are chiefly responsible by releasing hormones in response to stress through the synthesis of corticosteroids, such as cortisol, and catecholamines, such as epinephrine, or adrenaline or norepinephrine. These endocrine glands also produce androgens in their innermost cortical layers. The adrenal glands are located in the retroperitoneum superior to the kidneys. Its weight is from 7 to 10 grams. They are surrounded by an adipose capsule and renal fascia.
Which is epinephrine and norepinephrine. They also produce androgens. The adrenal glands affect kidney function through the secretion of aldosterone, a hormone involved in regulating the osmolarity of blood plasma. Cortisol, aldosterone, and androgens, while the medulla chiefly produces epinephrine and norepinephrine. In contrast to the direct innervation of the medulla, the cortex is regulated by neuroendocrine hormones secreted from the pituitary gland, which are under the control of the hypothalamus, as well as by the renin-angiotensin system.
Cortex.
On structural and anatomic characteristics. The adrenal cortex exhibits functional zonation as well. By virtue of the characteristic enzymes present in each zone, the zones produce and secrete distinct hormones. Receives input from the sympathetic nervous system through preganglionic fibers originating in the thoracic spinal cord from T5 T11. Because it is innervated by preganglionic nerve fibers, the adrenal medulla can be considered as a specialized sympathetic ganglia. Unlike other sympathetic ganglia, however, the adrenal medulla lacks distinct synapses and releases its secretions directly into the blood. Cortisol also promotes epinephrine synthesis in the medulla. Produced in the cortex, cortisol reaches the adrenal medulla and at high levels, the hormone can promote the upregulation of phenylethylamine and methyltransferase PNMD, thereby increasing epinephrine synthesis and secretion.
Each adrenal gland has two distinct structures, the outer adrenal cortex and the inner medulla, both of which produce hormones. The cortex mainly produces cortisol, aldosterone, and androgens, while the medulla produces epinephrine and norepinephrine. In contrast to the direct innervation of the medulla, the cortex regulated by neuroendocrine hormones secreted from the pituitary gland. Cortex. The adrenal cortex is devoted to the production of corticosteroids and androgen hormones. Specific cortical cells produce particle hormones including aldosterone, cortisol, and androgens, such as androstenedione. Under normal and stress conditions, the human adrenal glands produce the equivalent of 35 to 40 milligrams of cortisol accepted per day.
During periods of stress, such as preparing to run in a race, the brain signals the adrenal glands to produce epinephrine or adrenaline. Epinephrine increases the rate in which the heart beats. In turn, the increased cardiac output supplies more oxygen to the muscles, putting the body in a heightened state to react. As a longer-term response to stress, cortisol is secreted by the adrenal glands, promoting the release of energy.
The adrenal cortex contains three zones or layers. These anatomic zonations can be appreciated at the microscopic level, where each zone can be recognized and distinguished from one another based on structures and anatomic characteristics.
Hi, I'm Elizabeth Bloomberg, and I'm talking to you today about understanding the connection between nutrition and stress. Now, I'd like to give you a better understanding of how the adrenal gland works. The adrenal gland is your stress-coping gland, and it's responsible for a wide variety of functions. First, it's very helpful in regulating the blood sugar levels. It supports metabolic function, and of course, it helps in terms of stress management. Cortisol is a hormone that's secreted by the adrenal glands during the stress response. So I'd like to take you through an understanding of how stress is actually perceived by the brain. When the stressful event occurs, the brain gets the signal and it's received by the hypothalamus, which then sends the signal through your pituitary, and finally the adrenal gland receives the message that it's being under attack. From there, cortisol is then stimulated into the bloodstream, which sends a flood of fat and sugar into the body. Now, this fat and sugar is going to be used for the quick energy that the body needs to fight or flight. Now, it's very important here that we understand the difference between the way in which our bodies respond to stress in modern day times versus in what we can call prehistoric times. So let's take a look back at how one might have responded when they were in fact threatened by a dangerous predator. Let's say we have a caveman who's being chased by a dinosaur. Well, his body receives the stress response and he runs for his life. Well, the fat and the sugar that's flooded into his bloodstream gives him that quick energy that he needs to outrun the danger. Now, modern day society, our primitive brain does not know the difference between being chased by a dinosaur or just being told by your boss that you have a deadline to meet in 24 hours. So, the end result is still the same. Sugar and fat are flooded into the bloodstream in order for the body to have quick energy to fight off the danger. The problem is that most of the time we don't have the physical outlet to be able to actually burn through that extra sugar and fat. So what ends up happening? We end up storing that sugar and fat, especially around our midsection, which is the most dangerous place to store fat because that surrounds our organs and puts us at risk for diabetes and heart disease.
Medulla. The adrenal medulla is the core of the adrenal glands and is surrounded by the adrenal cortex. It secretes approximately 20% noradrenaline or norepinephrine and 80% adrenaline or epinephrine. Cortisol also promotes epinephrine synthesis in the medulla, and it is produced in the cortex cortisol reaches the adrenal medulla at high levels. The hormone can promote the upregulation of phenylethylamine, increasing epinephrine synthesis and secretion.